In this video, we're going to talk about control logic or control flow in Kotlin. And that's going to come down to 4 statements. If, when, for, while. What you'll see is that these are very, very similar to things that you've already seen. In some cases, they'll look identical to what you have seen maybe in Java or C#. In other cases, they're not exactly the same, but they're so close, you'll understand the concept pretty much immediately. So let's start with if. So for an if statement, we need a couple variables so I can demonstrate. So let's do val number 1 equals 10, val number 2 equals 100. So just a quick recap, what have I done here? I've created 2 variables called number 1 and number 2. They're vals, meaning the value cannot change. They're immutable. I've assigned one 10, the other one 100. 10 and 100 are integers. So the inferred data type, these become integers. And let's create one more variable. We'll call it var bigger number. And again, just default this to 0. So in this case, we create a variable called bigger number. It's a var, meaning it's mutable. So we can change the value. I've assigned it 0. A 0 is an integer. So the big number variable data type is integer. So if statement. Very, very basic. So if I want to see, check, to see which number is bigger, I could say if number 1 is greater than number 2. And I could say bigger number equals number 1. So very, very basic here. I can do an if statement in one line. But there's still already a few things that we can pick up about how the language works from this. So inside here, it's a Boolean, just like you'd expect. Notice I did put parentheses around the Boolean statement. That you do need to do that in Kotlin. Not all languages, by the way, do you need that, but some you do. And then after that, I immediately followed it on the same line with, the code I wanted to execute. In this case, bigger number equals number 1. So it's the most basic way. So if we expand that out just a little bit, of course, it doesn't have to be on one line. And normally, honestly, I'm not a big fan of this. Usually we like to break things out just a little bit more. There are times when this is a good way to write it, and I can't tell you when you should do it on one line versus when you should break it out. That's just something that comes with experience, but you should always be asking yourself, when someone comes in and looks at this code and knows nothing about this system, but has to sit down and understand your code, what is the easiest to read and understand? That should always take precedence. What's the easiest to read and understand? So probably a better way to do this. Also, if number 2 is bigger, we're not doing anything. So let's rewrite this. So we'll do the same thing here. Number 1 greater than number 2. But let's break it out into multiple lines. So we use curly brackets, just like many other languages, to have a block of code. And now I can have, one or more lines of code here. We're only going to have one, but I certainly could have many, many. So now we'll say bigger number is equal to number 1. And we could do, just like every other language in the world, we could do else. Number 2. So what are we doing here? We're going up. We're comparing number 1 to number 2. If number 1's bigger, we assign bigger number the value of number 1. Else, bigger number, number 2. So we're going to kind of keep moving here. You should understand if statements are pretty easy. Everything that you'd expect, you can do compounds. So I could check, is number 1 greater than number 2? And then we could say something like, or number 1 equals 0. I don't know why you'd ever want to do this, but right, we could combine them. To do ors, it's double pipe, just like Java, and is a double ampersand. So if statements work, off the top of my head, I can't think of anything different between Kotlin and Android, honestly. So you get the idea there. We can also, you may wonder, could we have done all this on one line, like we did up here? Yes, you can. And the way you do it, this is the one part that is unique to Kotlin, I believe, at least compared to Java. let's create another variable called, I'll call it biggest number. And I can assign it directly to if. So I could say if number 1 is greater than number 2, number 1, else number 2. So it's kind of interesting that you can do this. This is something that until, well, yeah, Swift actually has something very similar to this, but this is fairly new. I don't remember ever seeing this until the last few years showing up in languages. But you know, the idea is that you can run an if statement, and the if statement is just going to have one value, and that value then gets assigned back to the variable you assigned to it. So it's kind of neat. We will see this, or you saw something very, very similar to this if you think back to the variable lecture where we talked about optionals and how you would want to unwrap that optional. You'd want to get the value out to make it a non-optional variable so that you could work with it. And if you remember, we had something very similar. We'd create the variable, check to see if the variable's null, return a value. Otherwise, we would return a default value. And we could also use the Elvis shortcut, if you remember. So that's why this exists. This isn't something you normally get in the habit of using, but it can be handy. So something to keep in mind. And that's it for if statements. Not much more to say. Actually, we'll just leave all that up here and we'll keep going. Okay, so next. When. So when, to me, it's a little strange. I don't know why they did this, but when is a switch statement or a case statement, depending on what language you're working in. But it all works the same. It's like a big, switch statement or select case or whatever from language. So for example, let's do var I equals, and let's start off with just number 1. Oh, darn it. Okay, so I could say when I, and then let's say 0. Let's say what I want to do is take I and I want to convert it into a word. So I could say when 0, print line 0. And I could say 1, and then I do the little arrow, print line 1. So actually, let's go ahead and run this so you can see what's going to happen here. What you should expect is what happened. We print out 1. So when is, like I said, it's a big switch statement. So you put something in here that I want to potentially run out a whole bunch of different options. And you can go through. So when I is 0, this executes. When I is 1, this executes. And once it executes one of these, it doesn't run the rest. You don't have any break statements like you would in C. And then some of the things that are really nice about this is there's more you can do. So I could say 2, 3. Here we'll cover a couple concepts at once. 2, toe. 2, and then let's run another statement here. Or maybe 3. So what's going on here? So if we come down, when I is 2, 3, so when it's in this list, 2 or 3, then instead of a single line, if I want to do have multiple lines of code execute in the case of I being 2 or 3, I just put a curly brackets around it and can do as many lines of code as I want. So that's pretty slick. But there's even more. It gets more exciting, if that's possible. I could say 4, ... 10. We'll go back to single line now. Between 4 and 10 inclusive. So just make sure all this is still working here. Let's do 3. And also make sure I don't have any typos in my code. What did I do? Oh, sorry. Forgot the keyword in. Okay, so it's a special thing called a range. So I got to say when, think of it as when I equal to 0. I don't want it to be I equal to the range 4 to 10. I want to say it's in a range, and the range is 4 to 10. Subtle difference. But when I in 4 to 10, print line there. So now we run here, I is 3, so we get 2, maybe 3. If I change it to, let's say 6, we get between 4 and 10 inclusive. But what if we had 60? If we have 60, right? Nothing happens. Well, we could catch that at the end with an else. I don't know. So now when we run it, we'll print out, I don't know. So a when statement. Just think switch, and you should be in good shape. Okay, for loops. For loops, depending on what you've done with Java or other languages, some of this may be familiar, some of it might be a little bit different. But for the most part, for loops over the years have kind of changed into iterators. As opposed to what you don't see much anymore is kind of old-fashioned C for loops where you had, you know, for I equals 0, I less than 10, I plus plus. You don't see that very much anymore. So I'm not going to bother kind of covering that type of syntax, but just kind of the way things are used in modern times. So to show this, I'm going to go ahead and create an array list. Because you will use array lists a good bit. I'm going to make my array list a data type string, and then we'll stick with a theme for, and type out a few words here. So for loops typically you're going to use them pretty much almost all the time to run through arrays, array lists, sets, different collection types. And there's really two ways that I think you're going to use it. You'll find yourself using it for the most of the time. The first one is with an iterator for loop, where I could say for, and I don't know, we'll call I, because I don't really know what to call it, in numbers. So for I in numbers, and then I have my little block here. And so now what's going to happen is this block will execute once for every item in this list. And this time there's 3 items, so it's going to execute 3 times. And each time I is going to refer to this value individually. In fact, you know what, let's not call it I, I'll call it num. I think that's a little bit more clear. Because it's not, I don't want you to think that it's an index. What it's going to return to you is this object, this string. So now I could say print line number is $num. So if I run this, what's going to happen is we're going to print out 1, 2, 3, unless of course I made a typo. Ah, there we go. The number is 1, 2, 3. So for loop, you'll do this a good bit. I mean, it comes up a lot. There is another way to do it, and which way you do this is probably considered a little bit more modern. I will comment this out because I'm going to have it print the exact same thing. So there is an iterator built into most collection objects, and it works like this. So what will happen now is the exact same thing that happens up here, is that numbers is going to run. It is going to run once for each one of these, and a variable, which doesn't show up here yet, will point to each one of these objects that are in this collection. The variable is called it, and you'll see it show up a lot. Anytime we're doing these iterators, you'll see it shows up, and it just is referring to whatever it is. So I could do the exact same thing up here. In fact, I can just copy this line of code, paste it down here, and instead of $num, I'll do $it. And remember, doesn't have, it's only relevant inside of a string, and it's what tells the compiler that use this variable, right? Normally, unless you're putting it inside a string, you wouldn't say $it, just to kind of make sure that's clear. But now when I run this, we're going to get the exact same output. The number's 1, 2, 3. So pretty simple. It's just you got to remember that each instance will be assigned to the variable called it. And also, you know what? Let's just do it this way. Let's just print out. Since it's a string, I can just call print line on it, and now we'll print 1, 2, 3, just to underline that there is a variable. It's called it, and it refers to each one of those. So that's for loops. Not all that exciting, but you will use them a lot. And the last one is a while loop. And it works exactly like you'd expect. Works pretty much the same in every language. is, let's say, greater than or equal to 0. Print line. Let's do count down, $ counter, and then we'll do counter minus minus. So let's run it, and then I'll talk about it. So now we see countdown misspelled, 10 through 0. D-O-W-N. There we go. So what's happened here? Well, first we started by declaring a variable called counter. I defaulted it to 10, and it is an integer because this is an int, right? It was inferred. And now I said, while counter is greater than or equal to 0. So counter is 10. Obviously, it's not greater than that, so we print out countdown and then the value. In this case, first time through 10. And then counter minus minus. So you should, well, it depends on what language you use. You may be familiar with this concept, but if you want to take an integer and increment by 1 or decrement by 1, you can use minus minus or plus plus. So minus minus decrements it by 1, so it turns counter into 9. Plus plus would make it 11. So in this case, we decrement by 1, check to see, is 9 greater than or equal to 0? Yes, it is. So we continue through the loop. So again, very straightforward. This should be more than enough information for you to do almost all the programming projects you'll run into when it comes to control flow. And certainly will give you enough that if you run into a problem you don't understand, you can look it up quickly and get the details on it. So we'll stop the video there.